So A. Oh, I like A. We're going to do A first using our steps. And then I'm going to show you that A has a shortcut. And you're allowed to use the shortcut if you want, but if you like to use steps for things, you can use the steps all the way through. So the question is, step 1 was solving a log equation, and this is a log equation because there's an x inside of a logarithm. Can we write as a single logarithm? Well, how many logs do we have? We have 3 of them. On the right-hand side, I have a log plus a log. What can I do with that? Let's put those 2 together. I can multiply. Do I have a single logarithm? No, I still have 2 logarithms. If I want to combine those 2 logarithms, can I do that if they're on opposite sides? No. So I'm going to take the time to move one of them over to the other side. So 0 equals log this one. Whoa, that looks like a double bracket. Minus 1. And then I'll subtract log 6x over to the other side. Sometimes people like to get all of their logs on one side right to the beginning. But if I move that log 6x over, remember, there's nothing left on this side. You have to write equals 0. What's the log law for subtracting? Divide. So I'll have log. On the top, I'll have x plus 6, x minus 1, over 6x. Good. We've got step 1 complete. So step 1 took us a little bit longer this time because we had 3 logarithms to start with rather than 2 logarithms. What's step 2? What do we do next? Exponential form. So what's the first thing I'm going to write here? Ten. Good. And then exponent? 0. Can you see why you're going to forget this step? Okay? Because this is beginning of step 2. Before I go too far in this, because I often do this step quick, and then you're like, nod your head and completely forget it later. You go from here, and the very next thing you write is a 10. You're like, there's no 10 in here. And there's no exponents in here. And so this next step, when I write 10 to the 0 equals x plus 6 times x minus 1 over 6x, looks so fundamentally different than the step before. And that is weird in math, right? Usually you can say, I followed my work, and I write the next step, and I go, yeah, that logically follows from the step before. And this step does logically follow, but it does not look anything like what we had before. And so you forget that, because you're like, it looks so different. And you don't want to write things down that look different. So you just blank, and you just stop. And you go, I don't know what to do. And then you start making up math to make an answer. Because you're like, I have to have an answer. So we change it to exponential form. And then what is 10 to the 0? What's it equal to? 1. So if I have 1 equals this, is this a type of equation that you've solved in the past? Yes, you've solved these equations in grade 11. These are rational equations. How do you solve a rational equation? Well, you get rid of the fraction. How do I get rid of the 6x? Multiply both sides by 6x. What will that do? Well, that'll simplify, and then I'll just get 6x equals x plus 6, x minus 1. Okay. What kind of equation is this? Quadratic. right? Because on this side, I'm going to have x squared plus 5x minus 6. Have you solved quadratic equations before? Yes, in grade 11. How do you solve a quadratic equation? Move everything over to one side, make it equal to 0. Whoa, careful. That'll just be minus x minus 6. Factor if possible, or quadratic formula. Luckily, this one factors. Becomes x minus 3, x plus 2. Wow. And so x is equal to 3, x is equal to negative 2. Look at all of this from here all the way down to here with step 3, solving for x. But it all used stuff that we've done in the past, which is nice. Okay? Final step, step 4, you need to check for extraneous roots. Now, watch what happens here, and it's going to tempt you into a bad habit. Plug in 3, go back to your original equation. If you plug in 3, do you ever take the log of a negative number? Is it negative in here? No. Is it negative in here? No. Is it negative in here? No. Smile. X equals 3 works. Plug in negative 2. Go back to your original equation. If I plug in negative 2, will this be a negative inside this logarithm? It only has to be a negative inside the logarithm once. Doesn't have to be a negative inside of each logarithm. Just negative inside of a logarithm once. You don't have to do anything more, but you do need to show that this is an extraneous root. I've now done 2 examples, and I just developed a bad habit in you. Because we're human, we look for patterns. And the pattern we saw from the first example and the second example was when the answer was negative, we put an x through it. And Mr. JR has talked about things being negative being bad, right? That's a little bit out of context because I said if you take the logarithm of a negative number, that's bad. And then you put an x through your answer. But in this case, sometimes you'll just associate the negative here to being bad. I can make a question with 2 negative answers where they're both good. I can make a question, if you'd like, with 2 positive answers that they both don't work. Nothing more frustrating than doing all of that work to get one answer. I have questions where there's one answer and it doesn't work. 6 years ago, very first question on the final provincial exam was a log question. Had one answer. The one answer didn't work. It was really not very nice because the first question of your exam should be easy or medium difficulty, so you feel like got through the first one. All right, I'm ready for this exam. Here we go. But the very first question on that exam was like, no solution. Crap. I just spent half a page of work, and my first answer is no solution. That feels wrong? Would you feel like that doesn't feel good? No solution? And you turn the page and like, oh, this exam's going bad. Right? And that was the very first question. It had no solution. But this one, the negative doesn't work. It's not because the number is negative. It's because you plug it back into the original equation and it's negative. What's that? Like I could make a log that looks like this. Log 3 minus x. Can you plug in negative 2? Yeah, that makes log 5. Can you plug in 7? No. 3 minus 7 is negative. That would be bad. So I can make things like that where negative numbers are good and positive numbers are bad. Okay, now I'm going to take all of this that we've done, make it a little bit smaller so you can't see it. That's great. Good job. And now you can see it a little bit better. I'm going to show you the shortcut for this one. The shortcut for this one works as follows. In this situation, we followed the steps, and step 1 was Can we write things as a single logarithm? Then step 2, change to exponential form. Step 3, solve for x. At this point here, go in purple, we can take a shortcut. The shortcut that we can take is similar to something that we did when we solved things where we had the same base. So, are you okay if I look at that and say, so if log of 6x equals log of x plus 6 times x minus 1, are you okay with saying it must be that 6x equals x plus 6 times x minus 1? You see what I did? Like, if log of something equals log of something, these somethings would have to be the same. Otherwise, if they were different, they wouldn't be true. How much does that save us? That's how many steps we just saved. So, now that only works if you have a log equal to a log. I can make this question a lot more not nice by just adding a plus 1 to the end. Then you would not be able to use that shortcut, and you would have to do step 1, step 2, step 3. So shortcut only works if you have a log equals a log, then the insides would have to be the same. That is, using logic, it works. Yeah, I like that. I never thought of that. Nice. That is a good bad joke. Using logic. Excellent. Oh, that's a good day. It's an excellent day. It's a good lesson, and now I have a new bad joke to use for the rest of my teaching career. Logic. Nice. Okay. Part B. We have a log equation. We have two logs. Step 1, get things together as a single logarithm. Can I put those two logs together? Yes, they have the same base, so we're allowed to. Adding is the same as multiply. Step 1 completed. Step 2. After you've got a single logarithm, change to exponential form. So use your definition of a log. What is this? This means 2 cubed is equal to, and I'm going to multiply that out, distribute that x squared plus 2x. What kind of equation is this? Well, this would be 8 equals x squared plus 2x. It's quadratic. How do we solve quadratics? Move things over, make it equal to 0. So we're now solving for x using all of our skills from the past. X plus 4 minus 2. Does it work? Yes. Well, you could, but you have to like change log 3 to log 2 of 8, and that's not really a shortcut. So this one I would say, no, we don't want to use the shortcut. Okay? Plug in -4. What do we find? Step 4, we find when we plug in -4, that's bad. You would take the log of a negative number. Plug in 2. That's a positive number. That's a positive number. 2 is good. Okay. 11, and 13 for practice.